So the threshold effect of mitochondrial dysfunction refers to the fact that in general it takes multiple insults upon the mitochondria before significant dysfunction ensues. And the reason for that is because mitochondria and your body in general are quite resilient, and they can, we can withstand quite a few insults before we begin to show clinical symptoms. But in general, the way that viruses or atypical bacteria or chronic overload with certain heavy metals or pesticides can affect your body is through making your mitochondria less efficient. So if, let's say, 50% of your mitochondrial function is really required for you to remain normal and be able to carry out your day without much fatigue, then each viral infection or each metal overload or each metabolic insult on the body can maybe take down your function by 5%. And then next year you get another problem, and that's another 5% of the function of your mitochondria that drop. And then eventually, if you get enough of these insults, and some of these insults tend to help each other, that's why we call them co-infections. So an infection that does something to your body that may not be that bad by itself until you end up catching COVID or something on top of it, and then that machinery, which is now ready to take off and allow that virus to take over your body, is already in place. All you need is a little exposure and you'll get really, really sick, and it will become harder for you to recover, as opposed to someone who has 90% of their mitochondrial function. They may get COVID and not even have any symptoms. So the reason why the dysfunction of the mitochondria can be so detrimental to the individual are two. Number one, mitochondria are the batteries of your cells. So they make the energy that you expend. They're not making energy, you have no juice. You're running out of battery life, and that's it. It takes a much longer time for you to charge yourself back up, and when you do charge yourself back up, it doesn't last as long. Exactly the way a battery works. So that's one thing. The second thing, which may actually be much more important on how much energy the mitochondria produce, is that mitochondria are essential parts of cell division. So when your cells get old and injured and get bogged down with infection and so on, the cell decides, okay, it's now time to divide so that we can put all those diseased mitochondria in one side and all the bad things on this side, and then have a pure and fresh daughter cell that is born from this diseased cell, and then this diseased cell goes and dies, and then this guy is healthy and he can do everything normally. Now you went from 50% mitochondrial function to 100% mitochondrial function. Well, the viruses that infect your body, they're not dumb. They know that this is how your body works. So they make sure that these cells are not able to divide so that the infection remains viable and can continue to be in your body. And so they slow down the process of mitosis and the generation of new, fresh cells in your body. And so people who suffer from mitochondrial dysfunction not only have low energy, they also have an accumulation of older cells in their body. And this state of senescence is associated with a 20-year reduction of the lifespan of someone with mitochondrial dysfunction, with chronic fatigue syndrome that is severe. And it tends to be that these folks die of the same things that old people do, cancers mostly. and heart attacks. So the body ages more quickly because we cannot give birth to new daughter cells, and this is an end result of the mitochondrial dysfunction and the threshold that needs to be reached before cells cannot produce energy and cannot divide.